This is a story about power, nuclear power, and about why big tech, the architects of our modern society, have started to love nuclear energy. And why you should be taking notice, a lot of notice, to this new phenomenon. We need more electricity, is the cry of today's tech billionaires. Some say it openly, others are thinking about it, and the rest are quietly trying to solve the issue. The root of the problem is a simple, ancient one: supply and demand. The digitalisation drive, broadband internet, smartphones, cloud computing and other technologies have fundamentally increased the pressure on energy supplies. The world consumed 25,500 terawatt hours, short for 1 trillion watt hours of electricity in 2022. But global demand is predicted to be between 52,000 and 71,000 terawatt hours by 2050. Our appetite is growing, and the rise of generative AI makes the issue more complex. Data centers like Microsoft's iOS supercomputer train large language models and then continue to run them off thousands of energy-hungry GPUs. The top-of-the-range chips being NVIDIA's export-controlled A100 and H100, and, in some cases, CPUs as well. There is little publicly available research into the energy consumption of these so-called bit barns, but one peer-reviewed paper predicts that global AI data centers will use between 85 to 134 terawatt hours of electricity annually by 2027. That would roughly match the current electricity consumption of countries like Sweden, Norway, and the UAE. Unless that demand is met, expect blackouts, shed loading, and other forms of energy rationing. So what can be done? Elon Musk has long championed renewables, namely solar, to help solve the problem. But other tech billionaires are exploring nuclear power as a way out for future energy crisis. OpenAI's Sam Altman and Amazon founder Jeff Bezos have both backed nuclear fusion companies. Unlike the pre-existing and proven nuclear energy technology, nuclear fission, nuclear fusion bonds two or more atomic nuclei together to produce a near limitless amount of energy without creating carbon emissions or harmful waste. It's how the sun and other stars are powered. Here on Earth, the technology is still unproven, but a significant development came in 2022 when US scientists achieved a net energy gain by fusing atoms together with lasers. Each fusion company seems to be taking a different approach to making the technology both scientifically and commercially viable. Bezos has invested in Canadian-based General Fusion, while Altman has backed Hedge to the tune of $373 million. In a bold move and another show of confidence in Altman, Microsoft has committed to buying energy from Hedge, which it claims to have its first power plant ready by 2028. The site will produce 50 megawatts or greater after a 1-year ramp-up period, the company has said. Google also has skin in the game, with an investment in startup TAE Technologies, while China's Tencent is backing Oxford University spin-out First Light Fusion, which is exploring a novel projectile-based approach to the nuclear fusion problem. The Biden administration is also taking the prospect of nuclear fusion very seriously, with Special Climate Envoy John Kerry unveiling an international strategy around the prospective energy source at COP28 in November. The UK, which has its own nuclear fusion strategy, has proven to be a hotbed of nuclear fusion testing, with a range of public and privately backed initiatives in and around Oxford in particular. It's a risky business, but if fusion doesn't take off, Altman has another iron in the nuclear fire: Oklo. Like Hedge, the company went through the Y-Combinator startup accelerator program when Altman was president. The business, which plans to create small nuclear fission power stations, is seeking to list on the New York Stock Exchange by merging with the Alt-C Acquisition Corp. Following shareholder approval in October, entities have until 12th of July 2024 to complete the SPAC in a deal that values the business at $850 million. Oklo expects that it will take under a year to build a powerhouse, with each site expected to be backed by customer power purchase agreements ranging from 20 to 40 years. Fuel and construction will cost $70 million for a 15 megawatt plant, which will sit on just 2 acres of land. At the heart of the proposition is the Aurora, a small fast reactor which is designed to be inherently safe, according to the company, and based on demonstrated technology. It will use spent fuel from a retired US government reactor, the EBR-2 reactor, which operated from 1965 to 1994. On the commercial side, the Oklo team have identified data center providers as potential customers owing to the amount of energy they consume, as well as the defense and industrial sectors. The business claims its costs will be highly competitive with other clean energies at a range of between $40 and $90 per megawatt hours. If that seemed like a hard to achieve task, the business also plans to create a nuclear recycling business. On top of that, Oklo's fast reactor approach differs from other small modular reactor designs, which include thermal neutron reactors, molten salt, and gas-cooled models. It is now planning to build 2 powerhouses in southern Ohio. Now, even if nuclear fusion or fission gives the technology industry the energy breakthrough it needs with AI, another important problem needs to be solved still. That issue stems from how data centers stop their hardware from overheating and becoming inefficient. There are 2 approaches to cooling the bit barns: by adopting air cooling systems, typically involving cooling towers, or by using a very common liquid, water. It is the latter method that is increasingly used by data centers, with Google claiming that they use 10% less energy and therefore generate 10% less carbon emissions than air-cooled data centers. But data centers can become increasingly thirsty, with one academic paper estimating that the global AI demand could account for 4.2 to 6.6 billion cubic meters of water withdrawal in 2027. Texas Tech University has estimated that the typical data center uses about 3 to 5 million gallons of water per day, the same as a large town. As for Microsoft's supercomputer in Iowa, it reportedly used 11.5 million gallons of water a month for cooling purposes. That represented 6% of its host town's total usage of water during peak summer months. Microsoft is seeking to expand the site outside of the US and North Virginia in particular, which has become the world's data center hotspot due to its tax breaks and high connectivity. The Netherlands and Ireland, namely around the Dublin region, have become the top 2 locations for data centers in Europe. South Dublin Council even went as far as to ban new data centers, citing water shortages and energy concerns, only for the decision to be overturned by the national government. In the Netherlands, there is a more positive story to be told. Google, which alongside Amazon, Microsoft and Meta has promised to be water positive by 2030, is even using industrial canal water to cool its data centers, instead of consuming drinkable/potable water. Amazon has also committed to using sewage/reclaimed water to help cool its data centers. More innovation and careful energy and water management will be needed going forward as the global demand for digital services continues to increase. But for all the talk of fancy frontier technologies, there may be one final very human problem for the technology companies, and that's labour. That's because as the big technology companies attempt to build the new renewable nuclear and data centre infrastructure of our future, they will come up against a skills crisis in the construction industry, both in the US and the UK and elsewhere. It's another irony of the knowledge worker economy, which could strike again.